Hey there, AP Psychos. Welcome back for our second lecture here on research methods. Today we're going to be looking at Module 6, Correlation and Experimentation. So these are some of the learning targets that we have for this module. Understanding the relationship between variables and describing positive and negative correlations and why they lack causation. We will understand illusory correlations. We will describe characteristics of experimentation regarding these terms: IV, DV, random assignment, control groups, experimental groups. Also, confounding variables will be another term that we reference today. And lastly, but not in this screencast here, we will be doing some implementation of the experimental method in groups where you guys will actually kind of get to design your own experiments. So let's go ahead and get into the content. So what is a correlational study, and what does it mean when we say two things are necessarily correlated? So when we look at the definition of correlation is a research measurement to determine the degree to which two variables are related to one another. So co means two, relation just means connection, right, between people or things. So correlations are used when experiments are generally unethical or an independent variable can't be manipulated. So that's why we generally use them. So for instance, if we're looking at lung cancer and the prevalence that it has to do with smoking behavior, right, we might say that there's a correlation between smoking and lung cancer. Okay, but it would be unethical for a researcher to provide tobacco to teenagers to study this particular relationship. So in this case, using a correlational study would be effective, right? Some other examples might be looking at maybe communication styles and divorce rates, tardiness of class, and your grades in your subjects, right? These are other examples of correlations. An advantage to correlations is generally that, hey, it happens outside of a lab, so maybe it's more authentic in a sense. Negatives, however, would be, well, it doesn't prove causation, right? Because we're only looking at a relationship. So correlations never prove causation. We do not manipulate or change variables. Therefore, we cannot say that this is the cause of something and gather data descriptively to make connections and see possible relationships. Scatter plots are generally used to display the relationship of that data within the correlation. So we use slope-intercept form here. You've all heard of a scatter plot. You know what a scatter plot is. But here we're looking at rise over run. So the y-axis is going to be our rise, and then our x-axis is going to be our run. So the x-axis will be the cause variable, and then the y-axis will be the effect variable. Obviously, we're not solving cause and effect here in correlational studies, but you get what I'm saying. So this is what you'll see when you're looking at questions on the AP exam. When it asks, is this a positive correlation or is it a negative correlation? They'll show you a scatter plot, and you'll need to be able to recognize what a negative correlation looks like and what a positive correlation looks like. So when we look at a table here, for instance, we're measuring the height and temperament in this sample here of 20 different men. Okay, and correlation coefficient equation I have down here is going to give you your relationship. Okay, your correlation. So that's what the R stands for here. Would be the relationship. You're not going to have to use this equation. For most cases, you just need to know what a correlation coefficient is. And in this case, if we were to look at this data on these charts, we could say that there is a relationship, right, between temperament and height. As you can see here, participant 1, subject 1, his height is 80 inches, his temperament is 75, right? And then we could look at something a bit lower, like here. Participant number 10, 60 in inches and 39. Okay, 77. Participant number 9, 77 inches tall, 81. All right, let's look at another one. Height in inches here. Participant 11, 64 and 48. Okay, so through these participants, through this data on this table, we could make an assumption that there is a possible relationship between height in inches and temperament. Okay, now if you're looking at this same data on a scatter plot, it would look something like this. Okay, this is how you would show a correlation, by putting all this this data of the x and the y intercepts onto the scatter plot, and then you're able to see where everything falls and look at it and make a decision on whether or not there is a relationship between the two variables. So in this case, there's a moderate positive correlation of about 0.63 in the relationship between height and temperament in men. Okay, so the x-axis right here, the cause, is going to be height, and then the y-axis here is going to be the effect, which will be the temperament of the men. So how do we measure correlations? Well, we look at something called a correlation coefficient, which is a numerical index or a statistical measure that shows us the relationship between these two variables. So over here we have an example of what a correlation coefficient would look like, and there are two major things that you need to make sure you're aware of. One, whether or not it's positive or negative, and two, the numerical value. Okay, so with the positive or negative value, this indicates the direction in which the correlation goes, whether it goes up or down, and then the numerical value obviously is going to represent the strength of the correlation, right? So a positive correlation, a perfect positive correlation will be +1. A perfect negative correlation will be -1. Okay. Anything below that is weaker. Just because it's negative doesn't mean it's not a strong correlation. It's just a different type of correlation. So, for instance, this is a moderate positive correlation of 0.44, and this number actually represents something. It represents the relationship between SAT scores and college grades. So it shows us that there is somewhat of a moderate positive correlation, not a strong positive correlation, but a moderate positive correlation. And so we can see that from this correlational coefficient that, there is some relationship between SAT scores and students' grades in college and university. So when we look at positive correlations, they look something like this. Okay, positive correlations kind of go up in a diagonal line. And in this case, you've got two sets of scores on your x and your y. Here, for instance, we could say weight and height. Okay, and both of these are rising at the same time. Okay, the closer the correlation is to +1, we will see two variables going up in closer unison, right? So the taller I get, the higher my weight goes. Exercise, okay, the more I exercise, the more my appetite increases. All right, another example of a positive correlation. And then negative correlations is a correlation where there are two sets of scores that relate inversely, where one set goes up and the other set goes down. So you've got two sets of scores on your x and y axis, and they both go in opposite directions. All right, so for instance, weight increases, my fitness level decreases. Okay, not always, but that's just an example, right? If my anger increases, my happiness decreases. There's a relationship there. If my sleep decreases, my fatigue increases, right? So these are just examples of where one variable goes one way, the other relates inversely, goes the opposite. So what would you answer here for this question? Which of the following is an example of a negative correlation? Go ahead and respond to the multiple choice question. So hopefully you had time to answer that question, and the answer is A, right? People who spend more time exercising tend to weigh less. Okay, you've got two variables going inversely of each other, exercise amount and weight. So let's look at another example here of a correlation. You've got two main variables. The main idea here is looking at wearing headphones, the frequency of wearing headphones, and studying effectiveness of students. So this is a perfect positive correlation. On our x-axis, we have the frequency of wearing the headphones, and on our y-axis, we have the effectiveness of studying. This would be a more realistic correlation of what you would see, a moderate positive correlation. And here it shows us that the effectiveness of studying increases when the frequency of wearing headphones also increases. So you've got both variables rising at the same time. A perfect negative correlation is going to look something like this, where you have studying effectiveness now decreasing in terms of the frequency of wearing the headphones, right? For some students, this could be the case, right? For some students, wearing headphones or listening to music when they study is not helpful for them. For other students, it's really helpful. It just depends on the person. And then, obviously, a more realistic example of what a negative correlation would look like. And then, lastly, we have a zero correlation, okay, which it's pretty self-explanatory. There's no relationship here, and you just got a bunch of random plots all over the place on a chart, which you might see on your AP exam as well. So go ahead and give this another shot. What would you estimate for the correlation coefficient to be in these specific cases? So is it positive or is it negative is what I want you to answer. So go ahead and give it a shot. All right, you had time to answer that question, and the three of these are actually all positive, okay? Because both variables in all three of these cases are going up at the same time. So lastly, we're going to look at a statistical phenomenon, and this statistical phenomenon is called illusory correlations. Kind of hard to say. I say it fast so I don't mess it up. Illusory correlations. All right, and this is when we perceive a relationship where none exists, or we perceive a stronger than actual relationship that's really statistically there. So the question of why do we do this? Why do we have these illusory correlations? And the answer is because as humans, we want order, right? So given any random data, as humans, we just look for order. We look for some kind of meaningful pattern to help explain what we see and also explain our superstitious beliefs that we have, right? So a lot of times, illusory correlations relate to humans' strange, superstitious behavior, okay? For instance, in this case, a sports fan wears a blue jersey the day her team wins. And then she decides to wear that blue jersey, that same exact blue jersey, from now on, okay? Every time that team plays. And is this blue jersey going to have an effect on her team's score and whether or not they win? Of course not. Any superstition that we have, right? Even things that might sound like there might be some correlational relationship between sugar and hyperactivity, right? Well, if you give kids sugar, it makes them more hyperactive. There's actually there's not a lot of research behind that. Weather triggering our arthritis, okay? Again, there's not much correlational research behind that. Maybe gamblers taking that dice and rolling it softly. All of that is superstitious behavior. It's illusory correlations. There's really no relationship between the outcome of one variable related to the outcome of the other variable. So the key point here is that when we notice random coincidences happening, it's not necessarily due to a reason, okay? It's just random, and it's just how things work. And stop looking for order and everything, because things truly are random. So here's the video on Freakonomics. I posted the link for you guys. If you want to watch it, you can. And it just kind of shows the advantages to correlations and the disadvantages to correlations, in the sense that while they do give us a relationship, there are sometimes these illusory correlations where it kind of brings up issues. Check it out if you're interested. All right, we're going to do a little correlation quiz here. The higher my GPA, the more money I get from my mom. This is going to be a positive correlation. All right, what is this? it's going downward, right? So the variables are inverse, so it would be a negative correlation. The more I brush my teeth, the less cavities I have. Negative correlation. There's no correlation here. Zero correlation. The more fast food I eat, the more I weigh. Positive correlation. Both are going up. What is this? Positive correlation. Okay, so if we look at this, the number 1 here in the top left would be a perfect positive correlation. Number 2 would be a perfect negative correlation. Number 3 would be a moderately positive correlation. And number 4, a moderately negative correlation. So make sure you remember these. This is something that you might forget when it comes to May and we're taking our AP exam. So come back and review this video. But these are the correlations. So go ahead and try this one more time, looking at the correlation coefficient, which expresses the strongest relationship between two variables. The answer is positive point. Sorry, I almost said the wrong one. Negative 0.91, right? Because it's closest to negative 1. 1.2. Again, that's not a correlation, right? The perfect correlation would be positive 1 or negative 1, not 1.2. Okay, so if you see anything like that, they're just trying to trick you. And then our AP exam tip for the day is make sure you take note of the emphasis on this. Correlation does not imply causation. Correlation does not show cause and effect relationship. Why? Because we are not manipulating any variables. We can only see possible relationship. So that's going to be it for this lecture. I've decided I'm going to end it right here, and then I'll post another video regarding experiments. So I don't have too long of a lecture for you guys. I want to condense these down. See you guys later. Make sure you watch the lecture on experimentation.